plants produce flowers to make seeds. To make a seed, the flower must be pollinated. Pollen from the male part of one flower travels to the female part of another flower, where the seeds are made. Most, but not all plants, have both male and female parts inside one flower. The stigma is usually in the center, and the stamens which produce the pollen are clustered around it. The petals act like an advertisement to attract the various animals that will carry the pollen from one flower to another. These insects pick up a good dusting of pollen that they then carry to the next flower they visit, where some of the pollen gets brushed off. The flower has now been pollinated, and fertilization can then take place to produce seeds. The reward that these animals are looking for is the nectar from deep inside each flower. And it's not just insects that perform this task for plants. Once fertilization has taken place, the plant will produce seeds. They will often use the wind to transport these seeds, and one of the best at this is the dandelion. Each of the dandelion seeds comes with its own individual parachute. This device works so well that a slight wind will carry the seeds high into the sky. There are so many adult plants here that there is no room for the next generation of plants to grow. So the dandelions need the wind to take their seeds miles away. New plants are formed, and the whole process begins again. Other plants also use wind to transport their seeds, and have seeds designed to glide, float, or spin through the air. Seeds for plants that grow near water might use the flowing water to move the seeds on. Or the plant might produce seed pods designed to explode and project the seeds a good distance away from the parent plant. But many plants use animals to shift their seeds about. The seed pods might have handy hooks which attach themselves to the fur of the animal as it passes, and then drop them off somewhere else. Or the plant might make tasty fruit which is eaten by animals who then effectively carry the seeds far away. Here's a runner bean plant growing, and speed it up. male sperm and female egg. For animal reproduction, the male sperm gets together with the female egg. The resulting fertilized cell then starts to divide, doubling each time, and turns into a baby. In humans, about 6 weeks after fertilization, the baby's heart is beating. The head, body, and eyes are also forming. By the 9th week, the baby can move. Its hands and feet are clearly formed, and for 30 weeks more, the baby continues to grow. The length of pregnancy is the time from when the egg is fertilized to the moment of birth. It's about 2 months for a dog, 5 months for a sheep, 9 months for a human, 11 months for a horse, and an amazing 21 months for an Indian elephant. This horse is about to give birth.
I'd rather she lay down first.
Yeah, because it doesn't fall.
As the foal emerges, the special liquid that surrounded it in the womb comes out.
I just want to check that other foot's as it should be.
Yeah, there, just split the bag out. Look at it in there. Wow.
All right, good girl.
Stay there, darling. Stay there, stay there.
That's all. Just pull as hard as you can. Hold on.
Yes.
And it's a boy.
It's a boy.
It's a boy.
It's yours. Have a sniff. It's yours. Go on, have a lick. Give it a clean. Get off.
In order for my car to run, it needs petrol. Petrol is the car's fuel. But people are a lot more complex than cars. In order to keep a human body functioning, we need many different fuels. The human body gets its fuel from food. We need fuel for energy to move around and keep ourselves warm. But unlike cars, we also need it for growth and repair. With the energy you get from eating a single slice of buttered toast, you could cycle for about 20 minutes, sleep for 2 hours, or swim 10 lengths of an average-sized pool. Everybody needs to eat a well-balanced diet, But how do we know which foods to select? We need many nutrients on a daily basis in order to stay healthy. Most foods are full of nutrients. In a market like this, you can buy all the nutrients our bodies need. There are three main nutrient groups in foods: carbohydrates, proteins, and fats. Hi.
Hi.
What's that? That's interesting.
Cassava.
What do you do with it?
Well, you peel it up, chop it and boil it. It's a bit like potato.
Carbohydrates are a high-energy food, and root vegetables are a good source.
There you go.
Thank you. Other foods high in carbohydrates are bread, cereals, pasta and rice, and fruits, which contain natural sugars. Protein is needed for growth. Fish is really rich in protein, so is meat and cheese. Fats are the highest energy food source. They digest very slowly in the body. If you eat more than your body needs, layers of fat can form underneath the skin, but you do need a certain amount of fat to help cushion the internal organs, protect the bones, and insulate you from the cold. Many of the foods we eat are very high in fat. There are other parts to our daily diet that we need in order to stay healthy. There are very many different minerals and vitamins that we need, each of which does a different job in the body. For instance, vitamin C helps us to heal when we cut ourselves. Vitamin D helps to build up strong bones, as do many minerals such as calcium that we find in dairy products, especially in milk. If you eat a good balanced diet of fresh food, you should get all the vitamins and minerals that you need.
What are human beings made out of? Well, a massive 95% of me is water, about this much. Quite a lot of carbon, enough salt to fill 6 salt cellars, enough fat to make 7 bars of soap, and enough iron to make a small nail. The stuff our bodies are made out of has to come from the food we eat.
So does that mean we have to eat nails?
This is a magnet, and breakfast cereals often contain iron, which we can prove when we keep stirring. Take out the magnet, and look, iron. Inside our chest, our lungs take oxygen from the air when we breathe. The oxygen is carried into the blood to the rest of the body. Air is about 1/5 oxygen, and oxygen releases the energy the body needs to stay alive. Healthy lungs can be damaged by things like smoking cigarettes. Tobacco smoke contains poisonous chemicals, including nicotine and carbon monoxide, and a sticky substance called tar. This smoking machine has a filter showing the buildup of tar after just a few cigarettes.
This is an example of tar. This thick, black, treacly substance has over 4,000 chemicals in it. We know that it causes cancer. We know that it causes a narrowing of the airways into the lungs. We know that it causes an increase in mucus production. And we certainly know that it damages the little hairs that line the lungs, which help to protect the lungs from dirt and diseases.
Over the last few thousand years, our lifestyles have really changed. We used to have to run to catch our food and to run to avoid being caught by our predators. But now we exercise very little. Because of this, our fitness levels have become quite low. Fitness involves many different areas. Take Lee, for example, on the trampoline. For him to keep exercising for a long period of time, he'll need to have a high level of stamina. Take the gymnast. He needs speed during his run-up and then strength to get the height that he needs to do the turns and twists in the air before he lands on the mat. But strength and speed are also important in our day-to-day lifestyles. Regular exercise is needed to get fit and then to stay fit and healthy.
The heart sits within the chest cavity between the lungs and is about the size of a fist. Essentially, it is a muscle that is a really powerful pump. The heart takes in blood that is low in oxygen from the body, pumps it through the right side of the heart and onto the lungs. In the lungs, this blood passes through very small blood vessels and absorbs oxygen. The now freshly oxygenated blood is pumped back through the heart again, and then onto the rest of the body. Inside the heart, there are valves which open to let blood through, and close to stop the blood from flowing backwards. The blood is pumped through blood vessels onto all parts of the body, where the oxygen provides fuel for the muscles and organs.